In the previous episodes, the students explored how to measure angles using radians. In this episode, they will continue to think about how many radians are in various amounts of rotation, but will also reflect on how this relates to degrees.
How many radians are in a full rotation?
A full rotation as in 360 degrees?
So,
Okay.
technically speaking,
2 pi.
it is 2, yeah.
2 pi?
Well, but that's not like radians.
Oh, yeah.
So, technically speaking, there isn't a 7th radian, but there's like 6 radians plus a little.
6 radians plus a little.
Yeah, because
And why
technically,
would that not be 2 pi?
2 pi, right?
I mean, like, it is 2 pi, but like, you can't really say 2 pi radians, can you? You can?
So
Never
you can.
mind.
It's 2 pi radians.
I was thinking of them as like the pieces, so I was like trying to like say how many pieces
I
there
see.
would be, but yeah, never mind. Ignore me.
Claire has pointed out a feature of radians that can be confusing, that you do not divide a circle into a whole number of pieces to find 1 radian. Unlike degrees, where you divide a circle into 360 pieces, and gips, where you divide a circle into 8 pieces, with radians, you divide the circle into about 6.28 pieces. This is because 2 pi radians fit in a circle. Now the students will explore how many radians and degrees are in various amounts of rotation.
Do you want to make a start point for your rotation? Sort of mark out a start point on your rotation.
Okay. Yep.
I
Okay.
used dry erase marker.
So if you were going to go a full rotation, you said it was going to be what?
From here, starting from here all the way back to here, so 360 degrees.
Okay, could you mark that out?
We're gonna use.
Yeah, use a fun color. Don't let me just keep using dark, depressing
And make sure
colors.
can you write it quite large?
Okay.
And what would that be in radians?
2
Equals
pi.
2
Pi.
radians.
All the way across the paper.
And if we were going to do an approximation, what would it be?
Like in terms, like what do you mean?
Equals about
6.28
6.28
radians.
radians. Okay, there we go.
That makes sense. So in a half rotation, what would that be?
Pi.
Pi, or 3.14.
Yeah, do you want to mark that out in a different color maybe? And mark out your...
No.
Yeah, we gotta use fun colors, man. I don't know. I have a fun color right over there, and I'm not
It's
using
like
it.
black.
Like, it's just the classic color.
Yeah. What about a third of a rotation?
About 360 divided by 3
What?
for a third of a rotation. For the degrees.
Yeah. Yeah, but like
Is
what I'm
120.
saying is like it would never be exactly 120 degrees because a full rotation isn't exactly 6. Like there's that little bit here.
But with just degrees, then 360 divided by 3 is 120. So 1/3 of a
Yeah.
rotation is always 120 degrees exactly because of 360.
But then what about this piece? Because there's 6 pieces plus this 0.28 of a piece.
Right, but if you're just thinking in degrees,
But
Can
if you like forget the radians.
No. Like I'm using the radians as degrees because there's. So what I'm doing is I'm thinking of it instead of. So I'm thinking when I'm thinking of a third, or 2/3, I guess.
Mhm.
Was it a third or 2/3 that you asked?
It was a
1/3.
third.
1/3. So I'm dividing the 6 by 3, and then I'm using that 2, so I'm doing 60 plus 60. Like, this is hard to explain. Here, I'll do a small circle. I'm not making it exact on purpose because I don't feel like doing that. But so I'm looking at these two, and then there's like that little itty bitty piece here where the point because here's 1, 2, 3, 4, 5, 6.28.
Right.
So technically, like,
Mary, I'm wondering if you could walk. I feel like you're trying to disagree.
Okay, so if a circle is 360 degrees and you divide it by 3, then each piece is 120 degrees if you're just not thinking about radians at all. So if we're thinking about radians, and you said that each radian's a little bit less than 60 degrees, that means that a little bit over 2 radians fit in a third of a rotation.
oh, I was thinking of it backwards. I was thinking of it like, okay.
Are you convinced?
Yeah, because what I was doing, like, I was kind of doing it backwards. Like, I was thinking of, instead of thinking of the degrees first, I was using the radian pieces to come up with the degrees.
I see.
So that's, yeah. If you divide the degrees into thirds, then it's an equal 120, and the radians would not be exactly 2.
What would the radians be then?
It's a little bit over 2, because each radian you said was a little bit under 60.
Yeah. Yep.
And so it's
Could you talk about it in terms of pi and then go from there?
Could we say like 2/3 pi?
okay.
Yeah.
What is 6.28 divided by 3?
I'm gonna figure that out.
Can you put that on the table so maybe
Oh, so you
just
can
sort
see
of
it, yeah.
what you're doing? Yeah.
2.8 divided by 3.
2.093 repeating.
Yeah.
So about 2.09.
Yeah. I'm going to put the 3 repeating because it's just repeating 3, so we don't really need to worry about that.
And what's our unit?
Radians.
Yeah.
Does this match
Yeah.
with like your thinking about there's about 6 radians in a full rotation?
Yeah, that makes sense. 'Cause
Yeah.
if 1/3 is about 2 radians, then 2, 4, 6. So yeah.
Yeah. I mean,
It's
because that's why
about-
I was getting confused in the first place, because I was thinking about the 7 pieces.
Yeah, because this full one is about 6.28, and then half is about 3.14, and then
Yeah.
a third is about 2.093 repeating.
That makes sense.
In this lesson, the students used a new unit of angle measure, radians, to both measure and draw a variety of angles. A radian is the measure of an angle at the center of a circle that cuts out an arc length equal to the radius of that circle. The students explained that in a full rotation, there are 2 pi, or about 6.28, radians, and 360 degrees. In a half rotation, there are pi, or about 3.14, radians, and 180 degrees. In a third of a rotation, there are 2/3 pi, or about 2.09 radians, and 120 degrees. Sometimes it can be a bit confusing to convert from radians to degrees and vice versa, because the number of radians in a circle is not a whole number. This means the number of degrees in a radian is not a whole number. Since there are a little more than 6 radians in a full rotation, each radian is a little bit less than a sixth of a full rotation. This means 1 radian is a little bit less than 60 degrees, which is a sixth of a full rotation. Now that the students understand how to measure angles, in the next lesson, they will begin to think about an object as it travels along a circular path. They will begin to coordinate how the measure of the angle of rotation changes and the height of the object changes as it travels along this path.